Hey, welcome back to this bootcamp series. In this video, we're going to continue practicing our JavaScript by creating a simple little math game. So before I talk anymore, let me show a sneak peek preview of the finished product that we're going to build together. So the game can randomly generate math problems, and if you get the question right, you get a point. Here you can see the green progress bar start to fill up. If you get 10 points, you win. Or if you get a question wrong, you can see it sort of zooms the question in red to alert you that you got a wrong answer, and if you get 3 wrong answers, you lose. Now, if you win or lose, it shows this sort of overlay, and then you can click the button to start over. Now, big picture, we're building this game for 2 reasons. Number 1, I think it'll be a fun exercise to practice more JavaScript. And number 2, the challenges that we're going to run into while building this segue perfectly into the topic we're going to cover in our next video. I'll explain what I mean by that at the very end of this video, but for now, I'm excited to start building the math game with you. Let's jump into the action. Okay, so I have a new folder here. So far I've just set up a basic skeleton HTML file. I'm loading an empty CSS file and an empty JavaScript file. If you're not sure how to set this basic skeleton up, that's okay. You can go watch one of the earlier videos in this series. Okay, but when it comes to building out this game, where should we begin? Well, if we look at the finished product, I think we should start with generating a random number, right? Every time I refresh the page, it generates a new math problem. So we're going to need to be able to generate or choose a random number from 0 to 10 with JavaScript. So how do you do that? Well, let's actually jump into our browser's console and we can take a look at how that's possible. So if we just inspect and then jump into the console tab, we can write a bit of JavaScript here. So JavaScript has a built-in object, uppercase math. This is just a core part of the JavaScript language itself, and we can look inside it, so dot, and call a method named random. So parentheses to call it. If we push enter, we see a number appears. Now if we push up on our keyboard, the up arrow key, we get the command we just ran, so we can push enter and run it again. And if you just keep pushing up and enter, you see you get a random number each time. However, it's always going to be a value from either 0 all the way up right before a value of 1. So it's never going to be exactly 1, but it could be 0.9998. So it's inclusive to 0, but not 1. So how does this really help us if we want to create numbers like 0 through 10, right? We don't just want a decimal or a fraction of a number. Well, if we know the largest number we want is 10, we can just multiply that by this, right? If this is always going to be some fraction less than 1, well, we can just say math, and again, that's uppercase math, dot random, parentheses to call it, asterisk, right, to multiply it by 10. So now, that gives me 6.9. If I push the up arrow and run it again, 0.4, 6.8. Okay, now before we learn how to round these to whole numbers, let's first address something, and that is that we would never actually get our max value of 10. Because if this is always going to return something slightly less than 1, well, then it's impossible for us to get 10. At most, we could get maybe 9.9 or something like that. So why don't we actually add 1 to whatever we want the largest number to be? So maybe uppercase math dot random times 11 instead of 10. Now it is random, so off camera through the magic of video editing, I'll run this until I get 10. Okay, so I finally got 10.6. Cool, that was just a proof of concept to show that it works. At this point, we just want to round these down to the nearest whole number. Well, maybe round isn't the correct term because since this is larger than 10.5, you would round up. But you know what I mean. Maybe not round, but just go down or return the nearest whole number in the downward direction. Right? So we'd want this to just be 10. We'd want this to just be 7. So what we can actually do is just wrap our formula within something called math.floor, which rounds down to the nearest whole number. So altogether, we could just say math.floor, parentheses to call that. Inside that, right, you give it a number and it will round down So that's where then we could say math.random, parentheses to call that, times 11. Let's run that. So we get 2. If I try it again, 8, 5, 3, you get the idea. So now that we've figured out a formula that works for us, let's copy this into our clipboard and jump back into our text editor. And let's jump into the JavaScript file that we've attached to our basic web page. And I'm going to begin by creating a function. You could call it anything, but I'm going to call it generate number, parentheses, curly brackets. Okay, inside the body of this function, let's say return, and then just paste in your clipboard, right? That formula that we were working on. Okay, now I want to make this function dynamic or flexible. What I mean by that is, what if in certain situations I want to randomly pick a number up to 10, but then in other situations I only want to pick a number between 0 and 2? Well, all we would need to do to make this function flexible like that is give it a parameter. So in these parentheses, you could call it anything, but let's call it max. Okay, and then instead of hard coding this to 11, let's get rid of the 11 and just say, new pair of parentheses, max plus 1. Right, before we wanted 10, but we added 1 to it for our math reasons. So now this is the same thing, right? We're just making it flexible. Now, if you're confused as to why I wanted to create a function out of this, let me show you. So down here, let's create a new function and let's name it generate problem, parentheses, curly brackets, right? Because if we look at the finished product, not only do you receive a problem when you first load the page, but then after every answer, we need to generate a new problem. So we would want a reusable function. Now in this, let's just return an object. So return curly brackets. Remember in our first JavaScript lesson, we created a cat object. I believe we named it Meows a lot, and it had different properties like species or eye color, and it had a method of jump. Well, in these curly brackets, we can give this object multiple properties. So let's drop down. Let's do this. Let's say it should have one property called number1, colon, right? That's the first number in the math problem. And we could just say generate number, parentheses to call it, say 10 is the largest value we want. After this line, we could say comma, have another property of number2. I'm just making up these property names, by the way. Colon, generate number, max of 10. And now here's the interesting part. So comma, one more property, and that is operator, right? If we look at the finished product, the mathematical operation is supposed to be random as well. So sometimes we want it to be subtraction or multiplication or addition. So here's how we can handle that. Just say operator property, colon, and then just give it an array. So square brackets. Inside there, I would just say quotes, the plus symbol, comma, quotes, subtraction, or that's just the dash symbol, comma, quotes. And yes, technically in JavaScript, multiplication is asterisk, but let's just focus on what the visitors should visually see, right? Most people don't know maybe that asterisk is how you multiply in JavaScript. So visually, we would want people to see X for multiplication. So let's just say X. Okay, now this creates an array, and then we know that after an array, you can say square brackets and then a number. So 0 would give you this first value, right? 1 would give you the next value, so on and so forth. So instead of hard coding this to a number, in these square brackets, we could just say generate number, call our function, give it a max value of 2. Right? So that's going to pick a number from 0, 1, or 2 at random. So that gives us one of these randomly. So let's go ahead and save this file and test it out in the browser. So if you refresh your page and jump into the console, we can manually run that generate problem function, parentheses to call it. Cool. So it's going to give us an object. And I think from here you can see how we just want to turn this into a user interface. Right? We want to display this to the visitor. Right? Number 1, operator, and number 2. So let me jump back to our blank page. Where should we begin? Well, we are going to want to store this generated problem in memory somewhere. right? Because the visitor could open this page up and then take half an hour to actually try to answer. So we need a way of accessing these same values again in the future to be able to check if their answer is correct or not. So let's do this. There are a million different ways you could set up this game, but this is what I'm going to do. Up at the very top of our JavaScript, let's create a variable. So let's say let state equal an object. And then inside that object, let's have one property of score. Let's set it to 0 right away. When you get 10 points, you win, but you start at 0, comma. Let's say wrong answers. Put that to 0 to begin with. Again, once you have 3 wrong answers, you lose. Okay, now let's think about when we need to generate a new problem and display it to the user. So it's when the page first loads, and it's after every correct answer, or if the game starts over. So let's create a brand new function. Let's give it a name of update problem, parentheses, curly brackets. And in this function, we want to do 2 things. Number 1, we want to generate a new problem and then store it in our state. But then number 2, we want to update the HTML user interface to actually visually display the problem to the user. So first of all, if we want to store it in state, we can just say, inside our function here, state dot, right? We're working with this object, state dot, let's name it current problem should equal, and then just use this function, generate problem. Okay, now that we've stored that in memory, let's focus on visually displaying the problem to the user. So to do that, let's jump into our HTML, and in our body element here, let's have an overall div with a class of main-UI. There's nothing special about that name, that's just what I'm going to choose, and if you want to be on the same page as me, you can choose this as well. Now to start, let's have a paragraph that will show our problem. So let's say p dot, let's give it a class of problem, right? By the way, in case you didn't watch any of the earlier videos in this series, I'm just using tab triggers here. So you can hit p dot, and then whatever class you want, hit tab on your keyboard. Anyways, now let's go into our JavaScript and select this problem paragraph. So maybe up at the very top, you can select HTML elements inline in your JavaScript, but I like to just select them once up at the very top. So I'll say const problem element equals document.query selector, and then we just give it a CSS-like selector. So quotes, dot for a class, and we give it a class of problem. Okay, so now we can access that HTML element with this problem element. So in this function, below this line, let's just say problem element dot inner HTML should equal, and then you could use quotes, but let's use backticks so we can do something dynamic inside the text. So the first thing we want to do is pull in number 1. So $ curly brackets to run an expression or do something dynamic. So that's just state dot current problem dot number 1. Okay, then we want a space, right? We don't want it all to run together. We want a space. Then we want the operator. So $ curly brackets, state dot current problem dot operator. We want a space, $ curly brackets, state dot current problem dot number 2. Big picture, we're just outputting the problem visually. Okay, now this is just a function definition, so we would actually want to run or execute or call this function when the page first loads. So right below this, we would just call update problem. Let's go ahead and save this, and back in the browser, if we refresh, cool, we see 9 times 6. If I refresh again, 4 plus 0, you get the idea. Now that we're displaying this to the user, I think the next logical step is to have an input field where they can try to type in the correct answer. So let's jump back into our HTML and add that. So right below our problem paragraph, but still within our overall sort of main UI div, let's just say form, hit tab. On the opening form tag, let's give it a class or an ID, it's up to you. I'll give it a class, so class equals quotes. Let's name it our-form. Inside the form, let's have an input field. So you can just say input, hit tab. Yes, we do want it to have a type of text. Again, we would want to give it an ID or a class so that we can hook onto it with our JavaScript. Say class equals our dash field. And then this isn't required, but I think it's annoying if the field tries to show you previous answers you've input into it. I don't think showing previous values makes sense in a math guessing game. So I'm going to say autocomplete and set that to equal off. Okay, then still within our form, but below the input, let's have a submit button. So just button, hit tab, let's have it say submit. Okay, let's save this and see what it looks like visually. Cool, so if I try to put in the answer and hit submit or enter on my keyboard, well, it completely reloaded the page, right? And you can even see it added a question mark at the end of the URL. We don't want that. So we don't want the default behavior when you submit a form in a web browser. We're not trying to send this data off to a server anywhere. We don't want to change which URL you're on, and we definitely don't want to reload the entire page. So we want to use JavaScript to prevent that default browserish behavior. Let me show you how we can do this. So back in our JavaScript, let's begin by selecting that form. So up at the top, let's say const. You can name this anything, but I'm naming it our form equals document.query selector. It had a class of our dash form. Okay, so now we have this that represents that form HTML element. Let's go down to the very bottom of our code here and let's say our form dot add event listener, parentheses to call it. So in JavaScript, when you have an object that represents an HTML element, it has a method, add event listener. When we call it, we give it two arguments. So for placeholder a comma b, the first is the specific type of event you're listening for. So are you listening for a click, for a mouse hover, for a scroll, for a keyboard press? In this case, we're listening for the submit event. So this will cover both our bases, whether the user clicks on the submit button or presses the enter key on their keyboard to submit. Either way, this event will happen when the user submits an answer. And then the second argument is a function that we want to run in response to that event happening. Now you could provide an anonymous or arrow function here, but just to stay organized, why don't we create a named function? We can call it handle submit. And then on a new line of code, we can just create a function with that name. So function handle submit, parentheses, curly brackets. Now we're circling back to the actual task at hand, and that is we want to prevent the default web browserish behavior of thinking we want to send this data somewhere and then completely reloading the page. We want to prevent that behavior with JavaScript. So to do that, in the parentheses for this function, we can include a parameter. You could name it anything, but I'm naming it E. This is short for event. Essentially, when add event listener calls our function, it's going to pass into it all sorts of information about the event that just happened. So that's what this is going to be inside our function. So in here, we can just say e dot prevent default, and that's a method. So we call it with these parentheses. Let's save this. And now if I reload, now when I try to type in my answer or submit the form, nothing happens. This is perfect. This is what we want. So now we can sort of make something happen ourselves, all with JavaScript. And we keep the user on the screen without trying to redirect them to a new URL. We don't want to completely re-render the page. At this point, I think the next logical step is to determine if what they typed in is the correct answer or not. So here's how I would do that. Back in our JavaScript, inside our handle submit function, right below this e.prevent default, but still inside the body of the function, let's create a variable and call it correct answer. I'm not even going to set it to equal anything on this line of code. I just want to create a variable with this name in this scope. Essentially, before we even worry about what the user typed in, I first want us to determine or compute the correct answer. So first, let's handle the situation if the operator is addition. And then once we have this up and running, we can set up the subtraction case and the multiplication case. So I'll say if parentheses, we can fit what we want to do if this is true all on one line, so we really don't need curly brackets. So we'll just say if If that's the case, then what do we want to do? We can just say correct answer equals, and then we would just look inside state.currentProblem and add together number 1 and number 2. Now actually, to save a lot of typing, why don't we create a variable that points towards state.currentProblem? Just so we don't have to keep typing this out over and over. So right here we can say const, name it something really easy to type like P. P for problem. So const P equals state.currentProblem. So then right here, this can just be P. So the condition is if the current problem, if its operator equals this, then correct answer should equal P dot number 1 plus P dot number 2. Okay, now that we have this, we can just duplicate this for the subtraction scenario. So just copy that line, say if P dot operator equals dash or subtraction, then the answer would equal number 1 minus number 2. And then finally, paste it in again. If the operator equals x, remember we wanted to visually show x instead of asterisk, well, then the correct answer would equal, and then we change the operator here to asterisk. Okay, now below all of this, but still in the function, now we can compare what the user just submitted in the form with this correct answer value. So let's set up another if, parentheses, curly brackets. In this case, we do want an else block as well, right? If the answer is correct or if the answer is wrong. For the condition, we're going to want to check the value of that input field. So let's go up to the very top of our document and select the field element. So you can actually just duplicate this line, change the variable name to our field, change the selector to our field. Okay, now we have this that we can use down at the bottom of our code. The condition is if, and before we actually grab the value of the input field, let's make sure that we parse it as a number or as an integer, right? Instead of a string of text. So you can just say parse int. This is a function in JavaScript, parentheses to call it. You give it 2 arguments, so a comma b. I'm not going to lie, the second argument is a bit over my head in terms of mathematics, but I know that if you give it a value of 10, this is going to sort of behave the way we would expect it to behave. It's going to parse it as a number instead of a string of text. So the first argument, instead of a, that's just the number that you want to parse. Or I should say the value or string of text that you want to parse as a number. So that would be our field dot value. Okay, so now this is going to be whatever the user submitted. And then right after that, so in between these 2 closing parentheses here, let's say double equal sign, we're checking for equality, if what they entered equals correct answer. Now you could set this to be a triple equal sign, and that will make sure that they're of the same type as well, because JavaScript can do some weird things where it converts one type of data into another type, right? Like the difference between a string of text, a number, a Boolean value. So to review, 1 equal sign is how you say that something should equal something. You're assigning that value. 2 equal signs is how you can check for equality. And then 3 equal signs make sure that the 2 values are also of the same type and there's no weird value coercion going on. Okay, but anyways, if this evaluates to true, that means they typed in the correct answer. So in the if block, just for a quick test, we can alert out and say, good job. In the else, that means they got the answer wrong. So let's say alert, try again. Let's give this a save and test it out. So back in the browser, if I refresh, let's try a value of 9. Cool, we see good job. Now, obviously, we didn't tell it to switch to a new problem yet, but if I type in something wrong on purpose, try again. Perfect. So now that we can tell if the answer is correct or not, we don't actually want to just display an alert. Instead, why don't we work on outputting this text here? If I zoom in a bit, you can see it says, you need X more points and are allowed to make X more mistakes. And then that way we can update these values if you get a question right or if you get a question wrong. So to do that, let's jump into our HTML and maybe right below the form, let's just add a paragraph and say, you need, and then I'm going to wrap the number 10 inside a span, so span tab, put 10 inside that and say, you need 10 more points, comma, and are allowed to make, let's have a span, 2 more mistakes. Okay, then let's give these spans a class or an ID so we can select them with our JavaScript. So I'll just say class equals maybe points needed. And then I'll name this one class equals mistakes dash allowed. Okay, if we save that and refresh. Okay, so now instead of the annoying alert pop-ups, we want to do 2 things. One, we actually want to keep track in memory the score, but then number 2, we want to visually update or re-render these values on the screen. Let me show you what I mean. So back in our JavaScript, within the if block, instead of the alert that says good job, we'd first want to increment our score in state, right? Up at the very top, remember we created this object state equals and as a property of score? Well, we would just want to increment that value, and then if you get the question wrong, we would want to increment this state.wronganswers value. So down here, instead of alert good job, let's say state.score plus plus to increment it or add 1 to it. Instead of the alert try again, we would say state.wronganswers plus plus. So that's task number 1. We affected those values in memory. Task number 2 is to actually visually update our user interface. Now we could select HTML elements down there in our if else, but I like to do that all up at the top. So up here we can just say const, let's call it points needed equals document.querySelector, and I give it a class, so dot of points dash needed. I'm just going to copy and paste, duplicate that line. This one will be named mistakes allowed, and the query selector was dot mistakes dash allowed. Okay, so now down in our if else, in the if block, in addition to just incrementing the score, we would also want to say points needed dot, and then we could use inner HTML, but really we should only use that when we need to actually set HTML. If you're just setting something that's plain text, right, in this case just a couple characters, we can instead just use text content should equal, and then we can just say you need 10 points to win, so 10 minus state.score. Okay, if you get the question wrong in the else block after this, we can say mistakes allowed dot text content equals 2 minus state.wronganswers. Let's give this a save and test it out. If I refresh, so this would be -7. Cool, you can see now I only need 9 points. Or if I refresh and get it wrong on purpose, cool, you can see now I can only make 1 more mistake. Now at this point there are several next steps we could take because there are several things we need to work on. So if I refresh and get the question correct, we would want to generate a new question if you get it right. And we would also want to clear out your previous answer and refocus this field for you. Okay, so that's one thing we need to work on. Also, if you get the question wrong and you just keep getting it wrong, we need to have some sort of logic that checks to see if you have made 3 mistakes or if you've scored 10 points. Right? We need the logic in place that sets up either the win condition or the lose condition. Let's worry about that a bit later. For now, let's set things up so that if you get the question right, it gives you the next question and clears out the input. So back in our if block, if you get the question correct, after these 2 lines, we can just call that function that we already created called update problem. Right? We already created this function up here. It's going to generate a new problem, store it in our state, and then render it to the user interface. Okay, so if we save that, refresh, if we get this question right, cool, we see a new question. This was also updated. Let's update that function though so that it deletes whatever is in the input field and reselects the field in case you click on the submit button. Right? So for example, if I say 0, but instead of pushing enter on my keyboard, if I click off that field and click on the submit button, we would then want this field to be reselected so you don't have to click into it manually. So within this update problem function, let's add a couple new lines. Let's say our field dot value We just want to clear out the previous value so that it's empty, right? So the user doesn't have to manually backspace or delete their answer. And then let's also focus the field. So our field, and then just call a method of focus. Let's save that and give it a test. So 16, I'll click on this button. So it reselected the field, automatically put my cursor there, and now I can just keep going. Cool, but notice that even if I get more than 10 questions right, well, I should have just won the game, but we didn't set up our win condition or our lose condition yet. So now let's work on that. So down in our handle submit function, regardless of whether you get the question right or get the question wrong, we're going to want to check the logic either way to see if you just won or if you just lost. So actually what I would do is right after the closing else block, let's just call a separate function. Let's call it maybe check logic. And then down at the very bottom, we can create a brand new function with that name. So function check logic. Okay, inside this function, I'd have two if blocks, and we could even give ourselves a comment to stay organized. So the first comment can say, if you won, and then if you lost. So for if you won, it would just be an if statement. The condition would be if state.score now equals 10. And the condition for if you lost would be if state.wronganswers equals 3. Now in either of these situations, we would want to display a message to the user, either congrats you won or sorry you lost. And then we would also want to reset the game in either case. Right? So you'd want to set their score back down to 0 and their wrong answers also back down to 0. So inside this if block, why don't we say alert, congrats, you won. But then also right below that, let's call a function that doesn't exist yet, but it will be called reset game. And then I'm just going to copy this into this if statement as well, only now it would say, sorry, you lost. Okay, now let's go set up the function called reset game. So maybe down here we can just say function reset game. So when the game gets reset, we want to do several things. First, why don't we generate a new problem or update the problem? So update problem, just call our function. We'd also want to set state.score to equal 0 again, state.wronganswers to equal 0 again. We'd also want to update the user interface in that paragraph, right? So let's say points needed.text content, that should equal 10 once again. And mistakes allowed.text content, that should equal 2 once again. Let's give this a save and see if it works or if I forgot something. So refresh. I'll get these wrong on purpose. So there's 1 mistake, 2 mistake. This third mistake should reset the game. Sorry you lost, and if I click OK, cool, we get a new problem, and this is reset. Off camera to save some time, let me try to get 6 answers correct. Okay, I just need 2 more. Cool, congrats, you won, and as soon as I click OK, score gets reset, new problem appears. At this point, we have the basic skeleton of the game up and running. For the next bit of the video, we're going to focus on improving the user experience. So if you look at the finished product, there's this cool progress bar, right? And as you get the questions right, it animates or fills up. Also, if you get a question wrong, notice this turns red and also sort of gives you a zoom effect. Also, when you win or lose, notice instead of the browser default alert pop-up, we instead blur the background behind in the actual game, and we have this sort of overlay screen that appears, and then you actually can click this CSS styled button here to reset the game. Now, if you're not interested in this user experience or design bits of the video, do go ahead and skip to the end of the video instead of just closing this out, because at the very end of this video, we're going to talk about the major problems with this application. Well, maybe not this application in particular, but just sort of the problems with front-end JavaScript in general. I'll give you a hint. It has to do with the disconnect between our values in memory and the user interface that we actually want to render. Discussing this will segue perfectly into our next video and next topic. But let's not get ahead of ourselves. Let's go ahead and set up this progress bar that sort of animates as you earn points. So to set this up, let's add a bit of HTML to our page. So back in our HTML, right below this paragraph with our "you need X amount of points" text, let's add a new div, and let's give it a class of progress. And inside it, let's have another div with a class of boxes, as in plural. And then inside of that, I want 10 divs, each with a class of box. Now you could just select this and copy and paste it so there's 10 of them. However, I want to show you a cool trick. This should work in CodePen, VS Code, or any other editor that has Emmet installed. I like VS Code because it has Emmet installed by default, but we can just say div.box asterisk or multiply 10, hit tab. Cool, we have 10 of them. Okay, finally, not only after all 10 of those box divs, but also after this closing boxes div, but still within the progress div, let's have a div with a class of progress-inner. So this will be the element that animates or fills up with green, and then these will sort of just be the 10 empty placeholders to visually divide up the progress bar in 10 equal chunks. So if we save that and refresh, visually we don't see anything because all of those divs are empty. But now let's just go write a little bit of CSS to make it come to life. So if you haven't already, in the head section of your HTML, go ahead and link towards a CSS file like this. Okay, I've already created an empty styles.css file. Here it is. So let's begin by selecting the box class. Right, there are going to be 10 of these. And I'm just going to say have a height of 40 pixels. And let's give it a border on the right side. Just on the right side. So border right, 1 pixel thick, solid. We don't want it dotted or dashed. Just a 1 pixel solid. For the color, let's say hashtag C7, C7, C7. Let's give that a save. Now this looks a bit odd, but it's because each div is going to sit on its own line. So instead, if we tell their parent element to use flexbox, then all 10 of those divs will sit on a single line. So let's do this. In our CSS, let's target the parent element, boxes, and just say display flex. And then because all of the content is empty, this still won't really take up any space horizontally. But if we say width 100%, that will sort of force it to take up space horizontally. Let's give that a test. Well, they all sit on one line now, but they're not taking up any space. So maybe in our box rule, let's say flex 1, right? So they all take up an equal amount of space. Let's give that a save. Cool. This is a move in the right direction. So now we can just give the overall progress div a top border and a bottom border, well, and a left border as well. Just basically a border on every side except the right side. So in our CSS, I'll say .progress border 1 pixel solid C7, 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 but I will say border right none, because we don't want a double thick border on the right edge since each individual one is already having it. So if we save that, cool. So we have 10 equal boxes. Now we just want to work on the green progress bar that sort of animates or fills up to represent your score. So back in our CSS, let's create a new rule for progress-inner. And I want to position it absolutely in relation to its parent. So first I want to tell the parent to use position relative. And then on progress-inner, we can say position absolute. We want it to use the full height of the parent, so top 0, bottom 0. And to start out, let's have it use the full available width, so width 100%. Let's give it a green background color, so background-color, hashtag 7ECC00. And I want it to be a little bit see-through, so maybe opacity 0.57. Okay, let's see what that looks like. Cool, so now instead of it always just being the full width, we need a way to change its size horizontally on the fly. So here's what I would do in order to get the smoothest possible CSS animations. Instead of modifying its width value, we actually want to use transform and say scale X. This way the web browser won't try to repaint anything else on the screen. It can just use the graphics card to actually re-render this one element on the page. So if we say scale x 0, that's going to make it invisible because it's 0% of its original size. But if you say 0.5, or you don't need the 0, just 0.5, semicolon at the end there, that's going to take up half of its normal size, right? Or if you give it a value of 0.9, that's going to take up 90% of its original size. Obviously, if you give it a value of 1, it will just be its natural size. So let's put this back down to maybe 0.5, but we don't want it to be centered. We want it to be aligned on the left. So we can just say transform origin center left. So the first value controls the vertical placement. This controls the horizontal placement. Let's give that a save. Cool. Now, when we change this value on the fly with JavaScript, depending on how many points you've earned, we don't just want the bar to change immediately. We want it to animate or transition. So let's say transition the transform property maybe over the course of 0.4 seconds, and we'll use the ease out timing function. Save that. Now, if you wanted to, you could go into your dev tools, and in the CSS panel, if you change the transform scale x value, you'll see that this animates. But for now, you can just take my word for it. Let's use JavaScript now to actually change that value when you get a question right. Okay, so by default, we would want this to have a value of scale x 0, right? When you first come to the page, you have 0 points. Okay, at this point, let's tie it all together with JavaScript. So back in our JS file, up at the very top, let's select that progress inner, the green div. So const, let's call it progress bar equals document query selector. It had a class of progress dash inner. Okay, let's scroll down to the if block for when you get a question correct. So currently we're incrementing the score, outputting the new text needed, and updating to a new problem. Right below that, let's just say progress bar. So this is an object that represents that one HTML element. We want to look inside it for a property of style. And I want to push dot again to look inside this, but you can see that VS Code is going to try to autofill this into something else. I don't want that, so I'm just going to hit the escape key on my keyboard. And now if I hit dot, I can look inside it. We're looking for transform equals. And now this is how we can change that value from within JavaScript. So I'm going to use backticks instead of just regular quotes, and then just say scale x parentheses. Inside this, I'm going to do something dynamic, so $ curly brackets, and then just pull in the score, so state.score divided by 10, right? Because that's going to give us a fraction. If you have 5 points divided by 10, that's going to be 0.5. Let's save that and test it out. So if I refresh, if I get a question right, cool. Let's also make sure the progress bar updates when the game resets. So if I get questions wrong on purpose 3 times, so I lose, right? And then I hit this button to reset the game, we would want the progress bar to go back down to 0. So here's what I would do. This line of code is responsible for re-rendering or updating the size of the progress bar. So instead of duplicating this in the reset function, I would just copy this into my clipboard. And then in its place here, let's just call a function. Let's call it render progress bar, parentheses to call it. And then we can call that in our reset game function as well. Let's just say render progress bar. And then we just need to create down here an entirely new function with that name. So function render progress bar, parentheses, curly brackets. Just paste in your clipboard for the body of this function. Let's save that and test it out. So if I get a few questions correct, cool. But now if I get them wrong on purpose to reset the game, cool. Now that our animated progress bar is up and running, let's switch gears and let's focus on showing an overlay, right, with sort of a transparent blurred white background. And then instead of the browser default alert, we have a bit of custom HTML that appears right about here in the middle. So for example, if I look at the finished product and get questions wrong on purpose, right, you see the background is blurred. We have this sort of full screen overlay, sorry you lost, and then you can style this content however you want. And then when you click this button, it resets the game. So let me show you how I would set that up. So first I would jump into our HTML and down towards the very bottom. So not only after our progress div ends, but even after our main UI div ends, after that, so just in the root of our HTML, I'd say div.overlay. Inside that, I'd say div.overlay-inner. Inside there, I'd have a paragraph that says, congrats, you won. Now, obviously, we'd use JavaScript to make this dynamic, but for now, let's just hard code it and get the styling up and running. And then let's have a button that says, start over. Let's save that. Now, we just want to use CSS to make this appear as sort of a full screen, semi-transparent overlay. So to set that up, let's jump into our CSS. Let's create a new rule for overlay. I want it to take up the full screen even if you scroll. So let's say position fixed, top 0, bottom 0, left and right 0. Let's give it a slightly transparent or see-through white background. So background color. Let's give it an RGBA value. I think this is the first time we've used this in this series. So the first 3 values, you give it a value of anywhere from 0 to 255. Now, if you max out all 3 values, red, green, and blue, that creates white. If you set them all to 0, that would create black. And then obviously a mixture of any other values can create just about any color in the world. So that's the first 3 values, red, green, blue. But then if you add a 4th value, that controls its opacity or transparency. So a value of 1 is it's fully visible. Value of 0 would be completely invisible. But if we say maybe 0.82, basically 82% visible, let's give that a semicolon at the end. If I save that and refresh, so you can see here's that content. It's positioned sort of on top of everything else. The background is just a little bit see-through. Okay, but now we would want to center this content both vertically and horizontally on the screen. So to do that, I would just say display flex, justify content center, and align items center. See what that looks like? Cool. Now let's set it up so that the overlay is invisible to begin with, and then you can maybe just add a class to the overall body element to both make it visible and to blur the main UI div. Here's how I would do that. So back in our CSS, in overlay, I would say opacity should be 0 and visibility should be hidden. Okay. However, if we go into our HTML, let's set it up so that if on our opening body tag up here, if we give that a class of overlay is open, be sure to save that just for testing purposes. If that exists on the body element, then we want to blur the content of main UI and then actually make the overlay visible. So in our CSS, we can just say body.overlay is open. Look inside that for the overlay div, and then that's where we can set the opacity to 1 and visibility to visible. And why don't we have it so it animates open? So we can say on the baseline rule, transition all properties over 0.33 seconds using ease out. We can also maybe have it zoom, so it sort of zooms in. So we could say transform scale maybe 1.2. And then when it's actually open, we can just set it scale back to normal. So transform scale 1. Okay, now to make that main UI blurred, here's what I would do. Just create a new rule, say body.overlay is open. Inside it, look for the main UI div, and then just say filter, blur, with a value of 4 pixels. Let's save that, and if we refresh, cool, you can see the background content is now blurred. However, if we go into our dev tools and remove that class from the body element, right, so here's my dev tools, here's the body class. If I remove this overlay is open and push enter, notice how the overlay sort of animated or faded away. So now we just want to control that from within our JavaScript instead of hard coding anything in our HTML. So back in our HTML, on the body tag, get rid of this class. And then also down in the overlay HTML, let's hollow out the value for this paragraph text. So just an empty p element, because the overlay displays whether you win or lose, right? As long as the game is over, this will display. So we would want this to be dynamic, either a win message or a lose message. So we could give this p a class so that we can select it in our JavaScript. So class equals end message. Okay, let's save that. And then back in our JavaScript, let's find our function that's called checkLogic. So this is the win condition and the lose condition. So we don't want to show that annoying alert. So let's get rid of that. Instead, let's set the paragraph text to say, congrats, you won. Then as soon as we do that, we can add that class to the body tag to make the overlay visible. So let's go select that paragraph element up at the very top. Just say const end message equals document.querySelector. Had a class of end dash message. Okay, now we can go use this. So back down in our checkLogic function, within the if for the win condition, we would just say end message dot text content should now equal congrats, you won. Okay, now as soon as that is set, on the very next line, we can just make the overlay visible by saying document.body.classlist.add, call that method, give it a class, or a value, I should say, so a string of text of overlay-is-open. Okay, now let's copy these 2 lines of code into our clipboard, and then down in the losing condition, just get rid of that alert pop-up. Instead, just paste in your clipboard and change the message to sorry, you lost. Let's give this a save and test it out. So if I reload, if I get 3 answers wrong on purpose to see the error message, sorry, you lost. Cool. So now we want to set things up so that when you click this start over button, it closes the overlay and it sort of resets the game. So to do that, let's jump into the HTML and give this button a class so that we can select it with JavaScript. Back in our HTML, on that opening button tag, I would just say class equals maybe reset dash button. Give that a save. Back in our JavaScript, up at the very top, you can just duplicate one of these lines. Give the variable a name of reset button. The class was reset dash button. Okay, and then down towards the bottom of our code, within the checkLogic function, instead of calling reset game immediately, let's wait until you click on that button. So let's get rid of these reset game calls. Instead, maybe right above the reset game function, we can just say reset button dot add event listener. Call this method. The event we're listening for is when it gets clicked on, comma. The second argument is the function we want to run in response, which would just be reset game. Okay, and then to make the overlay disappear inside our reset game function, we can just remove that class from the body element. So right inside the body of this function, I would just add a new line and say document.body.classlist. This time it's .remove. The class we want to remove was overlay-is-open. Save this and test it out. So now, if I lose on purpose, sorry you lost, and if I click on this button, cool. However, I think it would be nice if you could reset the game just by pressing enter on your keyboard. What I mean is, if I lose on purpose again, I think the start over button should be focused so that I don't even need to take my hands off the keyboard and move my mouse to click the button. If it's focused, then I could just press enter on my keyboard, since that's already what I was pressing to enter answers into the input field, and then it would start the game over. Right, because if this is focused, it's going to register the enter button as a click. So to set that up, within our checkLogic function, we could try to focus the button as soon as we display the overlay. But remember that our overlay takes 330 milliseconds to actually animate into view. And in certain web browsers, if you try to focus an element before it's actually visible, it won't be correctly focused. It won't work. So to make sure this works in just about every web browser, I would actually just wait maybe 331 milliseconds and then focus the button. So right about here, right after we add the class that makes the overlay visible, I would just say set timeout. You give this 2 arguments, so a comma b for placeholders. The second placeholder is how many milliseconds you want to wait, the delay before your function runs. Let's say 331 milliseconds. And then the first argument is a function that you want to run. Now you could create a named function or you could create an anonymous function, but let's actually create an arrow function. So an anonymous function would just be function, parentheses, curly brackets, without giving it a name. Well, similar to this is an arrow function, and an arrow function is where you just don't need the word function. So you just have a pair of parentheses, and then this arrow symbol, which is just equal sign greater than squished together. Okay, and then if the body of our function is just one statement, we don't even need the curly brackets. So you could actually get rid of that. So just parentheses, arrow symbol, and what we wanted to do after the delay is just say reset button, and then call its focus method. Okay, let's copy this line of code and then just paste it down here in the losing condition. So right below that line, just like this. Let's save this and test it out. So if I lose on purpose, I'm just pressing enter on my keyboard. Cool, notice the reset button gets selected, so I don't even have to take my hands off the keyboard if I press enter again. Awesome. At this point, we're almost done. I'm not going to bore you with all of the super specific CSS for text align center and font size and font family. We've already covered that in earlier lessons. And if you do want your game to look exactly like mine, you can find a finished product CodePen link in the description of this video with my exact code. However, before we bring this video to a close, I do want to show you how to implement sort of the red animation. So when I get one wrong, notice how the problem sort of zooms in and turns to red for just a split second. So I do want to show you how we can set that up. So back in our copy of the game that looks like this, back in our JavaScript, above our check logic function, I'm looking for our function that checks to see if you got the question right or wrong. So that's our handle submit. And let's look for the if else section. So else, if you get the question wrong, this is where we would want to animate the problem to sort of turn red for a split second and zoom in a little bit. So within the else block, I would just say problem element, right? We've already selected that P element, and I would just say dot class list dot add. That's a method. Let's give it a string of text of, we could make up any name, but let's call it maybe animate dash wrong. Okay, and let's imagine the CSS animation takes 330 milliseconds. Well, once it's completed, I would want to remove this class from that element so that if you get a wrong answer again, it's ready to receive the class and animate again. So just right below this, I would say set timeout, give it 2 arguments, right? A comma B as a placeholder. Let's wait 331 milliseconds. After that amount of time, we can just include an arrow function here. So parentheses, arrow symbol, right? It's just equal sign greater than squished together. We don't need curly brackets if we just have one statement in the body of our function. And you could actually just copy this line of code, paste it right here, but just change the add method to be remove, right? We want to remove that class. Okay, let's save this. And now before we actually create an animation, let's first just create a style that makes the text red, just to see that this is working. So in our style sheet at the very bottom, we could just say dot animate dash wrong. That's what I named the class, and just say color red. Let's save that and test it out. So if I get a question wrong on purpose, cool, it didn't last very long, but if you watch this very closely, it turns red. Cool. So now to actually have it sort of animate or fade into red and maybe zoom in a little bit to really draw your attention that you got it wrong, let's do this. Instead of just saying color red, let's say animation colon 0.33 seconds, and the name of the animation we want to use, well, we haven't created the animation yet, but let's imagine we name it maybe show error, semicolon. Okay, so the web browser is going to use this animation and make it last this long. So now right above this, we just want to spell out an animation with this matching name of show error. So right above this, we say @ keyframes, and then the name of the animation you chose. So we made up a name of show error, curly brackets. Now inside here, you spell out what kind of styles you want to use at different percentages. So for example, I'll say 50% of the way through the animation, right? So as the animation plays, right, halfway through this time period, I want the text to switch to red, and I want to zoom in a little bit. So transform, maybe scale 1.2. And then you can set any other percentages. You could say at 75%, I want it to turn blue, or at 80% through the animation, do this or that. But I'm just going to say at 100%. So once the animation completes, it should just put it back to its standard color. So either a dark gray or a black, and put the scale back to normal too. So transform scale 1. Okay, but you're free to experiment with CSS animations. You can add intermediate points where it rotates or changes colors or anything you want to do. But let's save this and test it out. So now when I get one wrong, that did not look good at all. I think it would look a lot better if this text was centered. So let's see. In the CSS, we can just say dot problem. Make sure the text align is set to center. Let's try that out. So now when I get one wrong, I think that makes the animation look a lot smoother. But there you can see it's turning red and zooming in. If you wanted the animation to be a bit slower, that's not a problem. You could just change this from animation wrong, maybe bump it up to 0.45 seconds. And then back in our JavaScript, you would just want to wait that long before removing the class, right? So then you put this to maybe 451 milliseconds. Let's test that out. So if I get this wrong, notice the animation is a little bit slower now. Cool. Now again, I'm not going to bore you with the exact font sizes and text align center and padding and margin that I set up in this finished product, right? And the exact font family I chose, so on and so forth. But aside from those tiny CSS details, we have now completed our math game. Again, if you do want to see my exact finished styling code, you can check out the CodePen link in the description. But that is going to bring the technical aspect of this video to a close. Whew, that was another long video, but hopefully it was worth it and you feel like you learned something. Anyways, where do we go from here? Well, at the start of the video, I said that the challenges we would run into while building this app would segue perfectly into our next topic. Now, before I say what our next topic is, let's first discuss what the challenge was while building the math game. I would say is that it felt like there was this huge disconnect between our data and our user interface. So remember, we had an object, we named it state, and it kept track of how many points you have and how many mistakes you've made so far. Well, there wasn't any way for us to tie that data to the user interface in a way that didn't feel fragile or messy, right? It felt like we had to babysit way too many different HTML elements and update their text content at just the right moment, and all of these different moments. It just didn't feel very ideal or robust. And so this does bring us to our next topic, which is something called React. What in the world is React? Well, it's the world's most popular library for building user interfaces. And in our very next lesson, we're going to get started with it. However, before we jump into that next video, I am going to give you a little bit of homework. So I have a freely available 10-part playlist here on YouTube called The 10 Days of React. Now, while it would be helpful if you watched the whole thing, you don't need to. You really just need to watch day number 1, or the very first video, because it explains the problem that React is solving. Okay, and in my opinion, if you don't understand the problem that a tool is solving, you have no chance of ever truly understanding the tool. So for the next few nights, your homework is just to go at least watch day number 1 of the 10 Days of React. I think that'll set you up perfectly for our next video. Essentially, in our next video, we're going to use React to rewrite our math game in a much more elegant fashion. Anyways, that's going to bring this video to a close. If you've been enjoying this series so far, like always, I'd appreciate it if you could share the link with your friends and family. Take care, and I'll see you in the next one.